So this, come on. Uh-oh. Wait, I know what's wrong. There we go. So this is section 5-3. Whoa. I don't want arrows on the end of my things. No arrows, okay? So this is section 5-3, and this is called solving trig equations. And this is kind of a big chapter, so I'm going to be talking to you for a while. Big section. And this will be on a quiz on Tuesday, along with the identity stuff. Tomorrow we'll have a review worksheet and a review activity. Monday we'll review over 5.1 and 5.3, and then you'll take the quiz on Tuesday, okay? So solving trig equations, 5-3. So the first type of trig equation, and you have to kind of know your unit circle pretty well for this. So if they say 2 sine of x minus 1 equals 0, and they say solve that equation, you solve it just like you're solving an algebra problem, except instead of trying to get x by itself, you try to get it by cosine x, or sine x, or tan x, or whatever you're trying to do, get by itself, and then you have to look at your unit circle to find your answer. Get it? Okay? So how would I solve this if this were just x instead of sine x? What would I do? I'd add 1 to both sides, right? So I'm going to add 1 to both sides, right? And I get 2 sine x, God bless you, equals 1, and then I divide by 2, so I get sine of x equals 1 half, right? And then I have to go and I have to look on my unit circle. Where's my unit circle? Is this my unit circle? Unit circle, unit circle. That's not a circle. This is a circle. Circles look like this, okay? So here's a unit circle, and I have to say where on my unit circle is sine equal to 1/2. Where's sine equal to 1/2? You gotta know that. At 2 places, right? One is over here at. Why is there arrows? I didn't want arrows. No arrows. No arrows. Go back. Whoops. One over here is at. They're still there. Why is it doing that? I said I didn't want arrows. Okay. One more check. So one is over here at pi over 6. Okay. And the other one is where? 5 pi over 6 over here. Okay. So 2 places there and there. So your answers to this is x is equal to pi over 6, and then again at 5 pi over 6. But we're 150 degrees. But you can go around the unit circle over and over and over and over again. Okay? Because there are infinite places where sine of x is equal to 1/2. So in order to get all of them, this repeats every how much? 2 pi. So the real way to write this is pi over 6 plus 2 pi n and 7 pi over 6. Pi pi over 6. And 5 pi over 6. 5 pi over 6 plus 2 pi n. Guys, so this would account for every single solution where n is an integer. N is an integer, meaning -1, +1. So you could add 2 pi, add 4 pi, infinitesimal integer, like that. Okay? Yes?
Okay on like the test if we just wrote those 5 or 6 and
no. If they say find all solutions, then this would be your answer. Okay? If they say find all solutions where theta or x is between 2 pi and greater than equal to 0, then they mean this. Okay? So sometimes they'll say find all the solutions between 0 and 2 pi, and sometimes they'll say find all solutions, and then you have to add 2 pi to it. Okay? All right. So there's example number 1. Only 7 more to go. Okay. So next one. So the next type of problem that you will encounter, so if they say solve on 0 to 2 pi, so let's just solve this on 0 to 2 pi. Sine of x, where did that problem go? No, sine of x plus root of 2 equals negative sine of x. Okay? Anyone have any ideas how to solve that one?
Add sine of x.
Yes, you add sine of x to both sides. So I'm going to add sine of x here. Because you want to get the left side equal to 0. Well, not, maybe not. I'm going to add sine of x. And I'm going to, at the same time, I'm going to subtract root of 2. Subtract root of 2. Because then what I have is that sine of x, what does that say? Oh, I add, that's a plus sign. So I have 2 sine of x. This goes away. Equals negative root of 2. See where I'm going? Then what? Then what? Divide by 2, divide by 2. So I get that the sine of x is equal to negative root of 2 over 2. And let's just solve this one on the interval 0, 2, 2, 5. You understand what that means? Between 0 and 2 pi, not including 2 pi, because the 0 and 2 pi would give you the same value. So you start at 0 and then you go through 2 pi. So where on the unit circle is sine equal to negative root of 2 over 2? Who can tell me that?
3 and 4.
Connor.
5 and 4.
Negative, close, down here, and then down here. It's a multiple of pi over 4, but it's, so this would be, we call that 5 pi over 4. And what would you call this one from here to here? 7 pi over 4. 7. And that's your 2 answers for that. If they ask for all solutions, you'd add 2 pi into that. Okay? Easy enough? It gets way harder now. I'm sorry. Sure. It always does, doesn't it? Let's just take a test now. You ready to take a test? And for 200 points? No, on just these 2 problems. That'd be good, right? Yeah, but okay. So next type of thing. This is a little more trickier. 3 tan squared of x minus 1 equals 0. So you solve this just like you were solving for x squared equals 0. So what you want to do with this one is add 1 and then divide by 3. With me there? So I'm going to just skip a couple steps. I'm going to write that tan squared of x is equal to 1/3. Are you okay with that? Skipping those steps? Now, how do I get rid of this squared? Square root. So I get that tangent of x is equal to, and you have to do plus or minus the square root of 1/3. Right? Because if I square negative square root of 1/3, I get 1/3, and if I square positive square root of, and that's important that you have a plus or minus, because this is equal to square root of 1 over root of 3, right? Plus or minus, which is equal to, what does that rationalize to? Square root of 3 over 3. So what you now need to know is where on the unit circle is tangent equal to root of 3 over 3. Plus or minus. Anyone know? Come on, you can do it. I'll give you a hint. It's either multiples of 30 or 60. should memorize it. 30. It's 30. Okay? So you should know that tangent of 30 is root of 3 over 3. Tangent of 60 is root of 3. It just works out. You can put the y over the x and figure that out. But so what you're talking about is this angle, this angle, this angle, and this angle. All four of them, right? Because here tangent is positive, here tangent is negative, here tangent is positive, here tangent is negative. And those are every multiple of pi over 6. So if I'm in degrees, if I say find the answers from 0 to 360 degrees, not including 360, they would be, my answers would be 30. 30, what's next? What's this angle? 150, 210, and 330. Okay? If they asked you for all solutions, if they said all solutions, then notice that this one and this one are how far apart? How far apart is 30 and 210? How far apart is 150 and 330? 180. So if you want to write all solutions to that, you could write it like this. 30 degrees plus 180 times n, or 150 degrees plus 180 degrees times n, right? Because I could add 180 to this and get every other possibility. And I could add 180 to this and get every other possibility, because tangent repeats itself every pi, right? Your tangent's positive here, positive here. If I keep going around every pi, it's going to repeat. So I could add 180 degrees or pi radians. Okay, so if this were pi over 6 plus pi n, 1 or 5 pi over 6 plus pi n would give you all solutions. Yeah? No? That's example. How many examples have I done so far? 3. Okay. Solve. So next one. I'm sorry, but I got to teach you this. There's a lot. Okay? Next one, cotangent of x, cosine squared of x, equals 2 cotangent of x. Who wants to tell me what to do with that one? What do you think, Mitch?
Should you try anything this time?
No, you don't have to do that. Nah, don't do that.
Divide each.
What do you think, Connor?
Divide by cotangent.
Okay, so that's what I was hoping you'd say. You don't want to do that, okay? Because if you divide by cotangent, you're losing the fact that cotangent of x could be 0. And you're losing one of your solutions, okay? So I was hoping, that's okay you said that, I was hoping you'd say that. Because that's what most people would do. What you need to do is subtract, okay? So you need to get cotangent of x, cosine squared of x, minus 2 cotangent of x is equal to 0, okay? And then I factor out cotangent of x from both of those. You see that? Okay? See what I did? Okay, so now I have cotangent of x times what? Cosine squared of x minus 2 equals 0. And then I have 2 possible solutions. Either cotangent of x equals 0, or cosine squared of x minus 2 is equal to 0. Anyone know where cotangent of x is equal to 0? That's when cotangent is x over y, right? So x divided by y. Where is x equal to 0? Go ahead.
Pi over 2.
Way to go! Okay? So pi over 2 in another place also. And 3 pi over 2. Okay? Very good. Where is, so this one, watch. Cosine squared of x is equal to 2, right? Take the square root of both sides. Cosine of x is equal to plus or minus the square root of 2, where is cosine equal to plus or minus the square root of 2? Never. 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 Because remember, cosine is adjacent side over hypotenuse side. Cosine only goes between -1 and 1, right? So this would be outside of the range of cosine, outside of the domain. So you couldn't plug in a number bigger than you couldn't find a value in there. So this one you throw away, and so these are your two answers. Okay. If you want to find all solutions, it would look like pi over 2 plus pi times n. Because any multiple of pi would get you to that one, right? And add another pi, get you to the next one, and so on and so forth. So this is all solutions. This is between 0 and 2 pi. Questions? Okay, do you need a break yet? Not yet. Not yet, right? How about 2 more problems? Then we'll have a short break. And I'll tell you some jokes. No, I won't. I can't do that. That's against the rules. So, next type of problem that you may see is solve by factoring. Solve minus sine of x minus 1 equals 0. Huh? So this is just as if it helps you write a little problem like 2x squared minus x minus 1 and try to factor that. Huh? Who can tell me how that factors? Someone can tell me how that factors. I know you can tell me. What has to go here? 2 sine, not 2 sine squared.
Just 2 sine x.
2 sine x. What has to go here? Has to go here. That's sine x, right? What number has to go here and here? 1. Then you just have to decide which is minus, which is plus. Which one's minus, which is plus? I want minus sine x in the middle. So where should I put my minus sign?
On the left.
No, on the right. Right? 50-50. Good guess, though. Right? Right? Because this is going to, so if I multiply that out, that's going to give you this. And then you draw your little squiggly line. And you say that 2 sine x plus 1 equals 0. Sine of x equals -1/2. Or sine of x is equal to 1. Yes, sir?
Well, if you multiply -1 times 2 sine x, wouldn't you get -2 sine x?
Yep. You would. And then if I multiply 1 times sine x, I get 1 sine x.
Oh.
And -2 and +1 makes negative.
Forgot about that.
Right? We have FOIL. First, outer, inner, last. Have you heard of FOIL, Francesco? You have?
Not speak English.
Now, what do they say in Italian? You don't know. Never mind. Okay. You just say Lamborghini. Okay. So this is so sine is -1/2 here and here, and sine is equal to 1 up here only, right? And so that is what's that? That's 7 pi over 6, and then again at 11 pi over 6, and then this would be pi over 2. And so you have 3 solutions. If they asked you for all solutions, you'd add 2 pi n to that. Yes? Evan's trying to stay awake. You can do it, Evan. I know it's hard. One more and then I'll give you a break. So how about that? Any questions on that? You did? Okay. So next thing is when you have mixed up signs. That was my favorite book when I was a kid. Mr. Pine's Mixed Up Signs. Did you ever read that book when you were a kid? Mr. Pine is a dog, Mr. Pine, and he works at the sign factory, and he wears really thick glasses. And then one day he loses his glasses, and he puts all the signs in the wrong place, and it's really tragic. Mr. Pine's Mixed Up Signs. But that reminds me of another story. You guys have, oh wait, I have to tell you this story. Do you ever watch the Twilight? And okay, so on this one, it's a little bit tricky because you have sines mixed with cosines, and it looks like you're supposed to factor it, but I can't really factor sines and cosines. Anyone know what to do with that one? Anyone have any idea? Go ahead, Garrett. That's not going to help you. Can I change sine squared somehow? What do you think, Tegan?
I was just going to say change sine squared x 1 minus.
Perfect, okay? So what you do is you change sine squared x, you use an identity. You change sine squared into 1 minus cosine squared x, okay? Plus 3 cosine x minus 3 equals 0. And then you distribute and you try to simplify. So you distribute, you get 2 minus 2 cosine squared x plus 3 cosine x minus 3 equals 0. And then you combine like terms. This goes with this. So you get, I'm going to stick the cosine squared in front. Negative 2 cosine squared x plus 3 cosine x minus 2 equals 0. And for me, minus 1, sorry, you're right. Where am I supposed to? Minus 1 equals 0. And then I don't like to factor things that have a negative sign in front. So what I do is I multiply everything through by negative 1. Oh, there's the book I was looking for. Negative 1. Because what that does, I can multiply negative 1 times 0. It doesn't change anything. So then I can change this into positive 2 cosine squared x minus 3 cosine x plus 1 equals 0. And then you could factor that to 2 cosine x, what goes here? This has got to be a 1, that's got to be a 1, and I think they both have to be minus, right? Minus, minus, that works. And then you draw your little squiggly line, and it say either cosine x equals 1/2, or cosine x equals 1. And cosine x, who knows where cosine x is equal to 1/2? Cosine x. No, that's sine. Pi over 3, and then again where? Again. It's so pi over 3, and then again cosine is positive over here, right? What's that angle from here to here? 5 pi over 3, okay? Where is cosine equal to 1? Where's cosine equal to 1? Where's x equal to 1? 0, okay? So these are your three answers: pi over 3, 5 pi over 3, 0. And if they ask you for all solutions, you'd add 2 pi into that. Okay? All right, so I'm going to pause, and then you'll have some time to, I think I'm recording again. So if you see something like this, cosine x plus 1 equals sine of x, this looks like a very easy problem, right? But it's not that easy because there's no way really to solve this. Is there a way to solve this? Anyone have an idea of how I could solve this? What do you think there, Mitch?
Subtract 1 from both sides.
could subtract 1 from both sides, but that's not really going to help you either. Okay? What do you think, Jack?
Multiply each side by sine of x.
You can multiply each side by sine of x. Better yet, square both sides. Okay? Square both sides, and then what happens? This side square becomes cosine squared x plus, I FOIL this, so I have to multiply 1 times cosine x twice. So I get plus 2 cosine x plus 1 equals sine squared of x. And then I'm going to have to change this to match cosines, right? So what can I change sine squared of x into? 1 minus cosine squared of x. So I have that over there. And then I have this over here. Cosine squared x plus 2 cosine x plus 1. And then I get everything on one side. So I'm going to add cosine squared and subtract 1. So that gives me 2 cosine squared x plus 2 cosine x. And the 1's go away, right? See that? See the 1's go away? And then I set that equal to 0. And then I factor out 2 cosine x from both of these expressions. From that expression, cosine x plus 1 equals 0. And then I draw my little squiggly line. And I say that either 2 cosine x equals 0 or cosine x equals -1. And then I divide everything by 2, okay? Over here, so I still get cosine x equals 0. Where is cosine equal to 0? And again at pi over 2, and then again at 3 pi over 2, okay? But, and where is cosine x equal to -1? Come on. Where's x equal to -1?
Pi.
X equals pi, okay? So, but you have to be careful. So this is why they throw in this problem. When you square something or you multiply by a variable, you can introduce an extraneous root, okay? So you can get an answer that doesn't work in the original equation. So you have to take all those and plug them back in to the original equation to see if they work, okay? So if I plug pi in here, okay, my original equation, remember, was cosine x plus 1 equals sine x, right? So what's the cosine of pi? What's the cosine of pi? -1. So -1 plus 1. What's the sine of pi? Sine of pi is 0, right? So is -1 plus 1 equals 0? So this solution checks, okay? Now let's try it with pi over 2. Cosine of pi over 2 plus 1 equals sine of pi over 2, okay? And cosine of pi over 2 is 0, so you get 1. And sine of pi over 2 is also 1, so that one checks out, right? Now let's check out 3 pi over 2. Cosine of 3 pi over 2 plus 1 equals sine of 3 pi over 2. Is that true? No, because this cosine of 3 pi over 2 is 0, and 0 plus 1 makes 1. What's the sine of 3 pi over 2? -1. So -1 is not equal. So this answer, when you squared both sides, you introduced an extraneous root. So you have to throw out that answer. Okay? So when you square something that has a variable, or when you multiply something that has a variable, you have to check your answers in the original equation. Okay? 2 more examples. Well, 1 more example that you're not, well, 3 more examples? Really? No, 2 more examples. So you'll see some stuff like this where it says solve this is where it gets a little tricky. So solve cosine of 2x is equal to root of 3 over 2. Pay careful attention because everyone always gets this and wrong. On the interval, x is between 2 pi and 0. Okay? So what you do here is something called substitution. You let u equal 2x. Okay? Okay? So then you're going to solve the equation cosine of u is equal to square root of 3 divided by 2. Okay? But if x is between 0 and 2 pi, that means that 2x is going to be between what?
0 and 4 pi.
Yep, you have to double the interval, okay? So what you do is you look for answers, okay? This is the same as u, right? So you look for answers to u between 0 and 4 pi. So when you're doing something like this and you use what's called u substitution, you have to double the width of your interval. Okay, I'll show you how this works. Okay, so where is cosine equal to square root of 3 over 2? 30 degrees. We'll call it pi over 6, right? And then again over here, which is what? 330 or 11 pi over 6. So you have pi over 6, then you have 11 pi over 6, but you have to, so u is equal to this, right? Pi over 6, 11 pi over 6, but I have to go around again, okay? So if I go around the circle again, what is that called? How many pi's over 6 is that? Very good. Who said that? Very good, Cassie. 13 pi over 6. And if I go around the circle again from 11 pi over 6, how many is that? 23 pi over 6, because I'm adding 12 pi over 6. 23 pi's over 6. But this is u, and u is equal to 2x. I want x, okay? I don't want 2x. So how do you think I find x if I know 2x? Divide it by 2, right? So now I divide everything by 2. So I'm going to divide this by 2, divide this by 2, divide this by 2, divide this by 2, and I divide this by 2, and I get x is equal to pi over 12, 11 pi over 12, 11 pi over 12, 13 pi over 12, and 23 pi's over 12, right? And notice that all of these answers are between 0 and 2 pi, right? Where all these answers are between 0 and 4 pi, which makes all of these answers be between 0 and 2 pi. Do you see that? Okay? So these are your answers. Boom, boom, boom. And if you wanted to find all solutions, you would add pi n to all of those, because pi n will get you to this, and pi n would get you to this instead of 2 pi n. But you could just write it like plus pi n and you get all the answers. But graphically, just real quick, if I were to graph cosine, oh that's a bad graph. If I were to graph cosine of 2x, it goes up and down twice as fast as regular cosine, right? So it go up and down twice in 2 pi radians. And if I want to see where that equation, how many times would that line cross the line, where'd my tools go? How many times would that cross, this is my x-axis here, not a very good axis. But if this is y equals square root of 3 over 2, this would cross, here's the first solution, here's the second solution, Here's the third solution. Here's the fourth solution. Those are those four solutions on my graph. You see that? Okay? And they would, so this one, if I added pi to it, I'd get this solution. This one, if I added pi to it, I'd get this solution. Add pi to it, I get that solution. Okay? So that's where it gets pretty tricky. Last thing I promise. Okay? Last thing. So if I were going to do this, something like, hello, you done?
Yeah.
Okay.
Probably got most of them wrong.
Well,
That's okay.
it's
a thought that
okay.
counts.
It's a thought that counts.
Wait, guys, want to hear a joke? Want to hear a joke? Why, oh, wait.
Go ahead.
I can't remember.
So, going backwards, the last thing that, so what if I had said something like sine of x, sine of 1/3 of x is equal to root of 2 over 2. Could you do that? And you want the answer, so you want x is between 0 and 2 pi. Okay? X is between 0 and 2 pi. I just made up this problem. Okay? So if x is between 0 and 2 pi, x over 3 would be between what? 0 and 2 pi divided by 3, right? I divide the interval by, so that makes my job a little bit easier, okay? And so if I know that's, so I'm going to let u equal 1/3 x, okay? And so then I want, where is sine of u equal to root of 2 over 2, and u is equal to 1/3 of x. So where between, yes? Pi over 4, and where else? 3 pi over 4, but is 3 pi over 4, oh, 3 pi over 4 is, yeah, you're right. Pi over 4, 2 pi over 3 is like 120 degrees. So 3 pi over 4 would be over here. You're right. So, yep. So pi over 4, and then again at 3 pi over 4, right? Because this would be 2 pi over 3 would be short. Oh, wait. There's only one. 3 pi over 4 would be outside of this interval, right? So you don't. So it's just pi over 4. So you say u is equal to pi over 4. And since u is equal to 1/3 x, that means that x is equal to 3u, right? And so x is equal to 3 times pi over 4. Do you follow that? So I have to divide the interval, and then I multiply my answer. So here I divided my answer by 3, and then I multiply by 3 to get that. And this is the only place between 3 pi over 4 where x over 3 is equal to root of 2 over 2. That's kind of confusing, isn't it? Okay, I'm done, I promise. Sorry to talk so much, but that's...